Welcome back. In this video, we are going to look at section 4.1 in our workbook. 4.1 deals with ratios and unit rates. So a ratio is a comparison of two quantities by division. And often you'll see in math that division is written as a fraction. So that first example there, ratio A to B, can be written as that fraction A over B, where A is the numerator and B is the denominator. Or, you can use a colon to show ratio. So we have A and then a colon B to show A to B. And then we can keep that word 2 as a third way to write a ratio. So A to B that way as well. And since we can write ratio in fraction form, ratios can and should be reduced just like fractions are. Another characteristic of ratios is that common units in a ratio can be canceled just as factors are canceled, just like reducing would be. So if we're comparing apples to apples, the word apples can be canceled. And then also, just as fractions, ratios are written with whole numbers in the numerator and the denominator, and then the fraction is reduced to lowest terms. And again, that's in general. And so, for example, if we have the ratio of 2.7 to 3.0, those have decimals, and so we would want to turn that into a fraction without decimals. So we're going to get rid of the decimal point by multiplying by whatever we need to move that over. In both cases, they only have one decimal after, so if we multiply both by 10 and move the decimal over once for each time, we would get 27 over 30 as a ratio. And then we would need to simplify that. They're both multiples of 3. So 27 divided by 3 would be 9, and 30 divided by 3 would be 10. So we want to make sure that our ratio does not have decimals or fractions in it, and again, it's reduced in lowest terms when writing a ratio and working with it. Now, a rate is a ratio, but with different units in the numerator and in the denominator. When I think of rate, speed comes to mind, where we have miles per hour, so we have different units going on. And so when we're looking at rates, oftentimes we deal with unit rates. So for example, 25 miles per hour, we're looking at 25 miles per 1 hour. We wouldn't say that I'm driving at a speed of 150 miles in 3 hours. It's usually not how we talk. We usually use rate units of 1. So to make a rate, a unit rate, we're going to divide the numerator by the denominator, so that denominator is a unit of 1. So for my example of 150 miles in 3 hours, we would take 150 divided by 3 and say that we are driving at 50 miles per hour. So it says watch and work. That video, example 9, is in the lesson part of the Hawks homework, but let's go ahead and just look at it together. A bicyclist rides at a steady speed over level ground of 25 miles in 2 1/4 or 2.25 hours. Find her speed in miles per hour. So we're going to take our 27 miles per is where we can put our fraction bar, 2.25 hours. And we want to simplify it to miles per hour. So there's 2 different ways you can look at this. We know we're supposed to divide, so you could just take 27 and divide it by 2.25 and get the answer straight from there, which is 12 miles per hour. However, if you're trying to type it as a fraction into your calculator, the fraction will not let you put a decimal inside of a fraction. So again, we could get rid of the decimal. There's 2 spaces after the decimal here, so we have to move that decimal 2 places to get rid of it. So that means you would have to move the decimal here 2 spaces, and our decimal is understood to be here, so to get it back here, we would have to add 2 zeros. So we would make that 2700, or 2,700, over 225. And then we could simplify that, and it would still give us 12. And now that we have miles per 1 hour, we can just use the symbol or the shortcut MPH to stand for our miles per hour. So her speed, she's going 12 miles per every hour. So here's one for you to try. A swimmer swims laps at a steady pace of 6 laps in 1/4 hour. Find his speed in laps per hour. So go ahead and work this out. Let me help you set it up if you want to first before you pause it. We have 6 laps in 1/4 hour. So let's put L and H for hours. If we want to turn that into a decimal on the bottom, 1 divided by 4 is 0.25. And then you can work from there. Or again, in the calculator, since you're using the calculator, you can just do 6 divided by the fraction 1/4, and it'll give you the answer. But if you want to work it out this way, take your 6 over 0.25, change it to where there's no decimal in the denominator, and then get your speed. So pause the video and work that out, and then check your answer in just a second. Okay, so you should have gotten 24 laps per hour. Notice how I wrote my answer. This slash mark represents the division bar, or again, that word per. So you can just say laps, then a slash, and then hour. And that's just a shortcut way of writing it. So let's take a look at some true or false questions dealing with this topic. And if it's false, we need to fix it so we can make a true statement. Number 1, the units in the numerator and the denominator of a ratio must be the same or need to be able to be converted to the same units. And so let's take a look at that. We're dealing with a ratio. So yes, the ratios are one where they must be the same. And it says or need to be able to be converted to the same units. And this is true. We'll look at examples in just a little bit about what they mean by converted to the same units. One of our examples will show what they mean by that. So we'll wait for that clarification there. Let's look at some more. The order of the numbers in a ratio or rate is irrelevant as long as the numbers are reduced. That is false. Because a rate or ratio is in a set pattern. We have to keep the pattern the same, because if we want to look at miles per hour, we need to keep miles first, hours second. And so if we switch it, it's not the same value. So it's important. Not it's irrelevant. Yeah, I'm just trying to squeeze that in there. And of course, we need to reduce the fraction. Number 3, the ratio of 8 to 2 can be reduced to the ratio of 4. Well, 4 is an incomplete ratio. They did kind of try to simplify it, but 8 and 2 are both even, so 8 divided by 2 is 4, but 2 divided by 2 is 1. So they needed to finish putting that relationship of 4 to 1 there. And then to make a unit rate, we divide the numerator by the denominator. Yes, that is true. That's what we did. And that'll get us, for example, in miles per hour. So let's take a look at some practice problems. So I want you to try these. However, I want to point out number 6 before you do, because that's where we're talking about having different labels or different units for a ratio. So we have 5 nickels to 3/4. They're both money, so they're actually both in the same idea, so it can be a rate, but we need to put them in the same amount. So there's a couple different ways you can do that. You can look at it as dollar amounts. 5 nickels is worth 25 cents. So we can put it as 0.25 over 3/4 is 75 cents and look at it that way and then work with it. Or we can say that since 5 nickels is the same as 1/4, we can turn 5 nickels as 1/4 and have the 3/4. So there's actually the reduced answer. Or we can turn quarters into nickels. We have 5 nickels, and if there's 5 nickels per quarter with 3/4, that would be 15 nickels. And so again, we're making it where the numerator and the denominator are in the same unit. So here, cents, here we're referring to them in quarters, and here we're referring to them as nickels. And then, of course, all of them will be reduced to give us a ratio of 1 to 3. But try the others, and then resume the video and check your work. Okay, here's the answers. Notice with number 7, it said rate. So instead of canceling the dollars and just putting a 2 to 5th, we need to make sure we specify the rate of it being profit compared to invested money. So let's look at number 9. We have the unit price to the nearest tenth of a cent of the set of items and tell which one is the better. So figure out the cost per ounce for each and then compare. And pause while you do that and then check your work. Okay, for the first one, you get $1.13, and then it continues on, so writing it in cents, we would have 113.7 cents. For the 12 ounce, 66, and then rounded 1/10 would be 0.6 cents. So it's clear now that we have at units or base prices that the 12 ounces is a much better deal for coffee beans. So now let's look at some applications of what we've been dealing with. A serving of 4 home-baked chocolate chip cookies weighs 40 grams and contains 12 grams of fat. What is the ratio in lowest terms of fat grams to total grams? So we're dealing with a ratio, and the 4 home-baked chocolate chip cookies is just a description, and so that's not included in our numbers. We want to have fat grams, which is 12, to total grams, which is 40. And since it's a ratio and not a rate, we can say that grams cancels with grams. And so let's simplify. They're both multiples of 4. So 12 divided by 4 is 3. And 40 divided by 4 is 10. So the ratio is 3 to 10 for fat grams to total grams. In recent years, 18 out of every 100 students taking the SAT Scholarship Aptitude Test at a local school have scored 600 or above on the mathematics portion of the test. Write the ratio in lowest terms of the number of scores 600 or above to the number of scores 600 or below 600. Notice that's asking us to put a ratio with numbers that we don't necessarily have. This says 18 out of every 100, which is 18 out of the total. And so the 18 is above. So to get below, we would need to take the total, which was 100 students, and subtract off the ones that are above 18 to see that the number of students who scored below 600 is 82. And then we can set up our ratio. And so we have 18 students of 600 or above compared to 82, which are below 600. And again, we need to simplify that, which is cutting it in half, divide by 2, and we'll get 9 over 41. So the ratio is 9 to 41, above 600, or 600 and above technically, and below 600. Okay, so now here's time for you to jot down some of your thoughts. Demonstrate 3 different ways the ratio, comparing 5 apples to 3 apples can be written. Choose one form and explain why it is the preferred form when using ratios in a math course. So pause the video, write down your ideas, and then I'll show you what I have so you can compare, maybe add some extra to your notes. Okay, so the different ways, you should have the fraction 5 to 3, with a colon 5 to 3, and using the word 2, 5 to 3. And then there's my description of the preferred method. So your last one, when finding the price per mile, will monetary units be located in the numerator or the denominator of the rates? So what do you think? Well, if we look at the wording price per mile, the word per is our fraction bar. The price is listed first, so it should be in the numerator. And that's all we have for section 4.1. So if you have any trouble with the homework, please let me know. Otherwise, I'll see you next time.